So today we're going to be looking at section 6.4 parametric equations. Now before we begin, it'll probably be helpful for you to know a little example. This is Grace. Grace was a little upset and stressed about her math project. So Grace decides to bike off of a cliff. So this is going to be our curve here that we're going to use parametric equations in order to measure. And here we have the direction of motion. Now, the goal is students will be able to use parametric equations to represent a curve in terms of x and y set of ordered pairs. So, a parametric equation is an equation used to determine a set of ordered pairs that involves two functions f and g. And these are both going to be in terms of the parameter t. So these can then be used to find the rectangular equation form, which is an equation that you can graph. And an example of this might be y equals 4x plus 3. Then remember, the rectangular equation is easy to graph. So the parameter t is our third variable in a parametric equation, and that defines the limits of our graph. And an example of this might look like t equals -3 to 3. Now, this is going to indicate that only these t values can be plugged into the parametric equations, which limits our curve to points resulting from this parameter. And most of the time there will be a parameter, like -3 to 3, but in some cases we don't have a parameter.
Okay, we're going to get started with the definition of a parametric curve, which is also known as a plane curve. It is basically the curve created by plotting the collection of x and y points found by using the parametric equations. So really what you're doing is taking the points from your table and you're plotting them, and the curve that shows up is your parametric or plane curve. Next we have the direction of motion, which is the direction of the plane curve found, given by increasing t. It's usually denoted by arrows, okay? It's basically exactly what the word it says it is. It's the direction of motion. Okay, now we're on to our first example. So what we're going to do is we are going to graph this plane curve defined parametrically. This is our parametric equation. And then we're going to find an equivalent rectangular equation. So we're going to start off with making our little table here. And we start off with t first. Then we have x and y. So we have our parameters right here. These are our parameters. Okay, so we start at -2 and go up to 3. So -2, -1, 0, 1, 2, 3. Make this a little longer. Okay. So now to solve for x, we use this equation right here. Okay, x equals 2 times t. So you just do that, you know, -2 times 2. You got -4, -2, 0, 2, 4, and 6. Now to solve for y, we have t plus 1. So we just, -2 plus 1 is -1. And then we got 0, 1, 2, 3, 4. So now we have all our points. And now we can go ahead and graph. So we can just make our graph right here. I'm going to do my best to make it look even, but I mean, I make no promises, okay? Okay. Yes, I know it took a little while on that, but I think it was worth it, right? Okay, okay. So we're going to start with -4, comma -1 right here. I got -2, comma 0, 0, comma 1. So far, so good. Now we got 2, comma 2. We got 4, comma 3. And we got 6, comma 4. Okay, so we're just going to finish that. Alright, so now we have our line. So now we have our graph we are going to find our equivalent rectangular equation. So we take our two equations over here. We have x equals 2 times t, and we have y equals t plus 1. So I'm thinking that we're going to solve for t here and then put it in here. So we have our y equals equation. So we divide by 2 on both sides, and we get x over 2 equals t. Now we're going to take this, fill this in for t. We have y equals x over 2 plus 1, and there is our equation.
So, if we have the equations x equals 2t minus 1 and y equals the square root of 4 minus t squared, with the parameter negative 2 to 2, we're going to start off by drawing a chart. We're going to have t on the left, x in the middle, and then y. And we're going to plug in our t into the chart. So negative 2 to 2. And all we're going to do from here is plug in each t value into each the x equation and the y equation. So we'll start with the x. So 2 times negative 2 minus 1. So negative 5. And then do the rest all the way down. Okay, and then we're going to go to the y column. So 0, and then you get square root of 3. 2, square root of 3 again, and 0. And then square root of 3 is roughly equal to 1.73. From here, we're going to draw a little graph. Make sure you have enough space. And just plot those x and y coordinates. So, well, you can see that we took each t value and plugged it in to each equation, and that gives us our x and y values, and now we have our coordinates, so we can plot those. So, negative 1. Oh, did I do that right? What? And then here we have our curve. So we have graphed it and gotten the curve and the coordinates, but now we're going to want to find our rectangular equation for this problem. So in order to do that, we're going to take our two equations and we're going to take the one that seems simpler and try and solve for t. So we're going to do x in this case. Just go ahead and solve that out. So we have our t. Then from there, we're just going to plug that t that we got here, and we're going to plug that in as t for the y equation. Oopsie. And that is our rectangular equation.
Okay, so now we're on to the next example. So what we're going to do is we are going to graph a line defined parametrically and find an equivalent rectangular equation. So if t isn't given to you, which it's not, we have to look at the equations to figure out what the domain is going to be, okay? So when we look at this, we can just come up with a random window. We can just have it as a default as window is negative 10 to 10, okay? And now we're going to look at our t. And to figure out what our t is, we have to look and see what can't t be if these are our equations, okay? So we have x equals t squared and y equals t squared. It can be a negative number and it can be a fraction. So basically they can be anything. So that means that it is negative infinity to infinity, okay? So we can go ahead and write that in, negative infinity to infinity. All right, so now we're going to go over here and we're going to make a table. We have our t, x, y. Don't know why I brought that all the way over here. Okay, so now we can just choose any t values that we want. So we'll just go to a basic thing. We'll just go -3, -2, -1, 0, 1, 2, 3. Because our x and y values are going to be the same. So that means we're just going to be basically plotting 4 points. But you'll see that in a minute. So now we just put these into our equation for both of them. So -3 squared is 9. Okay, so now we have our points, and now we're going to graph them, all right? So I'm just going to go like this. Sorry, this isn't the best graph, but, you know, it'll do, okay? 0, 2, wait, no, 0, 1, it's not changed a little bit, okay? 1, 1, now we got 4, 4, now we got 9, 9. Hopefully you guys do this in a different spot than I did, all right? So this is actually a straight line. I'd like to point that out. This is a straight line. Okay. There we go. And we draw an arrow here because this is array. Okay. So I know it looks like it should have an arrow over here just because that's how most graphs do. But as you can see, it's not an infinite array in both directions. So that means the lowest it can go is 0, 0. And this makes sense because anything squared is positive, right? And our equations are both x equals t squared and y equals t squared, okay? So now we have to find our equivalent rectangular equation. You guys can do that, you know, make it look all cool and stuff. All right, so what we can do is we can just write y equals x, okay? And you remember how in the last example, or 2 ago, we decided that y equals is how we do our equations, all right? Because we have to have x on the other side, you know, okay? So this is our equivalent rectangular equation, and I want to tell you something about that, all right? And the equivalent rectangular equation has to correspond with the graph that you made. So we're going to write that in, okay? Has to correspond with the graph you made. So keep that in mind, all right? And so y equals x when x is greater than or equal to 0, okay? All right, because anything squared is positive, and you can have 0 as shown here. It's a straight line, okay? And we're done with that problem.